Assalamualaikum and welcome back to ESC 4603 Energy Systems and the Environment. So to this video, we are still going to look at the energy resources and technology. And without further ado, let's go to the next slide. Right. So we start off with the conventional energy resources. Okay. When we say conventional, it means that these are the resources that the world is using currently. So the majority of the world depends on these 5 energy resources. Okay, we have coal, we have petroleum and natural gas, we have hydropower and nuclear power. Okay, and if you look at the world's energy production, how the energy, or we look at this in terms of electricity, okay? How the electricity is being produced, it actually comes from all of these resources. Here we can have coal is usually used. Even here in Malaysia, we use coal with a mixture of natural gas. Petroleum, of course, but the major use for petroleum, I would say, is they are used in electricity generation. Okay? However, the large portion of it will go into transportation. Okay? So that fuels your car. Yeah? And if you only look at individuals, yes, our car, but if we're talking about, logistics, things where, you do delivery, right? So how does that van send your package to you? If we're talking about logistics, yeah. So this is why petroleum is such a close thing to us that it becomes really quite impossible to phase out, from the current use, despite it having many environmental issues. Okay, and we know that it leads to a very carbon heavy world, and we want to avoid that. However, there are some limitations. Okay? So apart from all of these 5, actually, not all are renewable. Okay, most of them are non-renewable. Yeah, coal, petroleum, natural gas, even nuclear power. And nuclear power is actually non-renewable energy. However, it only requires very little amount of the radioactive material, okay, to generate a lot of power. And that is why in developed countries such as the US, Japan still use nuclear power to generate electricity. Okay. Of course, we do have other types of energy resources and renewable resources, especially hydroelectric. This is one of the major producers if you're looking at Malaysia. Okay. And solar is quickly catching up. Yeah, we have also biofuel. If you've ever gone into the petrol station, okay, have a look at the pump head, the one that the handle, okay. There's diesel and petrol. Okay, for diesel one, have a look whether it's black or blue. Because the black one means that it's fully fossil fuel, okay, biodiesel. We're talking about diesel, yeah? This is diesel. For black means it's 100% fossil fuel. However, if it's blue, it means that there are some biodiesel mixed in. So at the moment, I think we are at B10. B10 meaning that it's 10% of biodiesel plus 90% of the pure biodiesel from fossil fuels. Okay, so we do see a lot of this coming in. Wind energy, geothermal energy. There's so many different ways to produce energy. Okay. So we look at first the non-renewable ones, yeah, and further along we will see what's up with the renewable ones as well. Okay, so first things first is coal. Yeah, coal was formed more than 300 million years ago from decayed swamp plant matter that cannot decompose in the low oxygen underwater environment. Okay, so just imagine a very, very long time ago, okay, when plants in swamps, when they die, their remains will build up. You can just imagine that when things pile up, okay, and over time, you know, there's sediment, and this creates layers upon layers of that matters and also sediment. Okay, and you know what happened? Okay, over time, okay, this what was previously a swamp, yeah, it was being covered by the plant remains, yeah, and as it is being decomposed, etc. Okay, somehow, okay, just imagine, because this is like millions of years ago. Yeah, now we have sea on top of it. So here it says that in low oxygen underwater environment, this plant matter, they cannot decompose, right? And bacteria will break down the organic remains, leaving behind mostly carbon. Okay. So imagine things that are at the bottom, and so many other things keep on piling on top of it. Okay, what would that feel like? Yeah, just imagine you are in that situation. You are sitting there and 40 of your friends are sitting on top of you. You would feel pressured. Yeah. So this is exactly what happens in this situation. Imagine here, the temperature and the pressure here would be higher than the rest. As you go down, the temperature and pressure will increase. Okay? And this situation, this condition, okay, it squeezed the material. Okay? And as it is being squeezed, it secretes out gas and moisture, right? And what is left is just this brownish material called peat. Okay, and peat, it keeps on being compressed and compressed because, you know, things are growing and dying and form the sediment. Okay, and it keeps on getting more and more pressured. Okay, this peat is compacted. Okay, and over time it changes into coal. So from peat into coal. Yeah. And actually, this is what happens. There's so many, there are different types of coal. Yeah? And the types actually depends on how long or how much pressure it was under. Because we want to, as it gets more and more pressured, it becomes more and more harder. Yeah? And we'll see a bit more about that. But first, I'm going to talk a bit more about the coal itself. Okay, so coal was the major fuel of the early industrial revolution. Okay, and if you can correlate, if you open the atlas, for example, the earliest cities, the industrial cities lah, it will be linked with the location of coal resources. Because, you know, the resources are here, it's easy for the industry to develop. So they don't have to bring over the coal to a longer destination. It's there, so you can use it. And that becomes the basis of the development of the city. Okay, so these are some of the examples lah. The Midlands of Britain, of Wales, Pennsylvania, Silesia, and German Ruhr Valley. Okay, these are some of the examples. Okay, and remember just now when I talk about the types of coal, okay, so these are some types of it. So lignite, we have subbituminous, bituminous coal, and anthracite coal, right? And you can see here what exactly it is. Yeah. So basically, I hope you still remember this one. Yeah, from peat into coal, right? Okay, and that is related to time and also the pressure and also the temperature. Yeah, so the longer it is, the higher pressure it was under, okay, and the hotter the environment was, you will get a better quality coal. Yeah? And if we look at that actually in terms of quality, anthracite is the highest grade. Yeah? Highest grade because it contains over 85% carbon. So with higher carbon, it is more efficient to burn actually. Yeah? And with higher carbon just now, you have lower sulfur content. So this is what makes it less polluting than the other types of coal. Okay? But of course, because this is the best quality, this is also one of the most exploited and it's almost depleted. So going down towards the less desirable coal is bituminous. Yeah? Bituminous is medium grade actually. It only contains about 50 to 75% of carbon content. It has higher sulfur content compared to anthracite. But it's definitely better than lignite. So lignite is actually the lowest grade of coal. Yeah, it only contains about 40% of carbon content. And it's most sulfurous and most polluting. Yeah, and even here you can see, if you link this with the situation that I presented to you before, okay, the ones at the very bottom here is anthracite. Okay, whereas here, these ones are actually the ones that are very recently turned from peat. It's slowly turning into coal. So that is why it is, the color is also different. You can see here brown coal and black coal, right? And here you can see that actually. Yeah. Right. So application of coal, I'm just going to be very brief here because we are going to look further into this when we study the electricity production. Yeah. But usually in coal, first 90% of its use is thermal coal. Right? And when we say thermal, it's not like you use it for barbecues, that's not it. Yeah. It's actually, you use it for thermal purposes. So you are burning it, okay, to produce high pressure steam in power plants. Okay, and this is what generates the electricity. Okay, so basically it's to generate heat, and that heat is used to heat up something, and that conversion of heat into mechanical power will generate electricity in the end. Right? Or it can just be used to generate heat, okay, which is what you can see in cement and lime plants. Okay. Now, it can also be used as metallurgical coal, okay, and this is actually in processes like in industry. So you can convert actually a metal ore to metal using coal, right? Because sometimes if you look at this in terms of reaction, okay, how one metal changes form, it requires carbon. Okay? And remember, coal has a lot of carbon, which is why it is able to donate its carbon to the metal oxide, okay, to form the metal itself, right? Okay, coking coal, and also there are new development in terms of coal where the rising energy prices, okay, will, although the price is higher, Okay, when we look at the environmental impacts, yeah, we are slowly trying to phase out coal as the energy producer, but we are trying to look into an alternative way to use coal. And for example, here, coal to graphite. Graphite is a very interesting material. If you have any sort of fascination or you are interested in nanotechnology, the graphite is actually one nanomaterial, one example of nanomaterials. Yeah? And it's easy actually. If you have a pencil, okay, that pencil tip, okay, the one that you write with, that is graphite. Yeah? So you can look it up. It has a lot of very interesting properties, and it has found applications in many different green solutions. Okay, so this is what I mentioned before, coal to electricity. Yeah, but of course we are going to look further about this in the electricity lecture. Okay, but just to mention, okay, because we are talking about energy resources, right? And in this situation, we're talking about electricity. So what is the major reason coal is used? Because it's cheap. And it is abundantly available. Okay. However, when it is combusted, okay, inside here, okay, and you see stack here, stack is where all the flue gas comes out. Okay, it actually contains CO2, SO2, and NO2 plus so many different things. They have heavy metals, so on and so forth. So when you release that into the atmosphere, it not only contributes to global warming, but also air pollution. Yeah, so that is some of the reason why we have to try to get a more better solution for our generation. Okay, so that is coal. Okay, we look now into petroleum. Okay, so petroleum actually, it is a big word lah. And petroleum actually collectively refers to crude oil, okay, natural gas, and solid hydrocarbon mixtures like tar and asphalt. Okay, and in petroleum, it contains other impurities such as water, sulfur compounds, oxygen, nitrogen, carbon dioxide, and traces of metal. Okay, so you can imagine if it is a Venn diagram, okay, where we say this is petroleum. Yeah, that's actually crude oil here and natural gas. Yeah, it is collectively referred to as petroleum. Okay, so crude oil. Crude oil is a mixture of hydrocarbons that exists as a liquid in underground geologic formation and remains a liquid when brought to the surface. And that's why it is crude oil. It is not natural gas. Yeah. So because if you compare with natural gas actually, it can be either in gas form, okay, or it can be soluble. It is soluble within the crude oil, okay, and then when you bring it up to the surface, it turns into vapor. Yeah, and one more thing is that natural gas actually contains 80% methane. So it's the majority is methane and other C1 to C4 hydrocarbons. Okay, so that is natural gas. It's different from crude oil because crude oil, it actually contains longer carbon chain hydrocarbons. Yeah. C1 to C4 here means, okay, you know what methane is, right? Methane is CH4. Okay, please recall back your chemistry. Okay, this is methane, so C1. Then you have if we say C4 means there's 4 carbon. Okay, so that is hydrocarbons, meaning that it's CH. Okay, now petroleum products. So petroleum products, the key here is products. Okay, and you can imagine when we say products, meaning that it's an end product. It doesn't, naturally, it's not like that. So it is being processed. Okay, it has undergone some kind of process and eventually becomes petroleum products. So what it actually refers to is the processing of crude oil and other liquids at petroleum refineries. And then from here, you will get so many different things. We're gonna see a brief example of it later on. Okay. Petroleum gas is gaseous petroleum, which mainly contains butane or propane. It uses natural gas as its raw material and then purifying it to much cleaner gas. Okay. So petroleum gas is more commonly known as LPG for household usage. Yep. Okay. Lastly is shale gas and oil. I don't know if you've ever heard about shale. Okay, but it's actually shale rock. It's one way to get oil, okay, not from crude oil, but from the shale rock. Yeah, so you can look it up. You can look that up if you're interested. Okay, so how was petroleum formed? Okay, petroleum is very interesting. It is actually being formed from marine plants and animals. Okay, and that died over 600 million years ago. Okay, very, very long time ago. So basically, but when we say here, a majority of that actually comes from phytoplankton and zooplankton. Now we do have seagrasses, on and so forth, but these two actually forms the majority of the source that eventually becomes petroleum. Okay. So very similar to coal just now. The only difference is the type of beginning it was. Yeah, so this one is more on the planktons. Okay. So this microscopic organism, it sinks to the bottom of the ocean. Okay, and then they were buried with other sediments. So very similar to coal. And the same thing happened. It gets buried and buried and buried, and it goes further down. There's so many other layers on top of it. And temperature, pressure, it rises. Okay? And when that happens, these microbes, because they are much, much simpler than the plants just now for coal. This microscopic organism, it is small. So it's easier for it to be converted into gas and oil. So this is what happens. So oil and natural gas are lighter than the surrounding rock. So once they have formed, they move upwards through tiny pores and fractures in the surrounding rock. Some are released to the surface through vents, while other deposits get trapped under impermeable layers of rock or clay. Okay, because there was no pores for it to go, right? So there's no option, so they have to be collected at one place. So these trapped deposits are where we find oil and natural gas today. Okay, so if you look up petroleum rig, usually it's somewhere in the seas, very deep seas. You see this oil rig. So this is what they do. They drill it through the impermeable rock, and they found the oil deposit. Okay, and they will be able to extract this oil and gas, so on and so forth, right? So the deeper the rock formation is located in the Earth's crust, the higher the temperature. Okay, so the type, remember there's so many different types of materials, not materials lah, elements lah, in petroleum. Okay, you know, we have natural gas, we have crude oil. So how those different things are formed, it depends largely on the depth of the source rock. Because why? It relates back to the temperature and also the pressure. Okay? If it's shallow, well, if it's shallow means it's not that deep underneath the earth. Okay? The temperature is usually around 60 to 80 degrees Celsius. The organic matter will be converted into heavy oil. Okay? But as you go deeper, lower depths here means that it's deeper, and deeper means higher temperature. Okay, 80 degrees to 175 degrees Celsius, the heavier long chain organic molecules began to break up into shorter molecules and form medium and light oil. Because it's so much hotter, it's so much more pressure, okay, then these oil will be broken further. Okay? The shorter molecules then form medium and light oil. Okay? But at places where the temperatures exceeded 175 degrees Celsius, the molecules become even shorter and lighter. Okay, and more matter is transformed into gas, okay, until the time when it reaches 315 degrees Celsius, it all is transformed to methane. Okay, that is the natural gas lah. Yeah. So the formation of oil deposits just now, it is, we can say that if you look at here, the oil production hits a ceiling. Because remember a few lectures before, we look at the theory of peak oil. Yeah, if you guys still remember, this is what it means. So deposit, the oil deposit, you can imagine lah, it's one, if it's one deposit and you keep on taking the oil out, we come to a point where it's depleted. There's no more oil, right? And what happens is, we know that it is a limited supply, okay, because it is created over the last 600 million years. Right? And how are you going to create more? You don't have enough time. Yeah. So one of the things that peak oil had predicted was, you know, you hit a ceiling, it comes to a point where cannot have more, and then production will go down. Okay, but what happened? If you guys still remember the table, the graph that I showed you before, okay, there are situations where naik pula, it goes up, it goes down, it goes up somehow. Okay? So why does this happen? This is because the exploration. Okay, exploration of new sources of petroleum, sometimes they found new oil deposits. Okay, and with this exploration, with this discovery, they were able to then increase the production. Okay, because let's imagine 5 oil deposits already closed because they're already depleted, but somehow suddenly they found 10 more. Okay, and then this sites will produce more and more oil. Right? And that is why the oil production, sometimes it increases beyond what was expected. Okay, and then of course, production versus consumption. This is actually talking about, you know, now if you know about the Russia and Ukraine conflict, okay, and you look at the price of oil, how does it look like? Whatever is happening out there, okay, not only in Malaysia, out there, throughout the world, it has its impact. Russia is actually one of the major oil producer, okay, and if there are any political problems, which relate to oil supply, you can expect that the price is going to go up. Yeah, because this relates back to economics. As you drive up the demands and you lower down supply, price is going to go up because higher demand would require the market supply more products, but they are not able to do that, so price will go up. Okay, so in crude oil, okay, imagine back again, crude oil. Okay, this is what is extracted from down there. Okay, it is extracted as crude oil, but we don't immediately use it. Remember petroleum products just now? Okay. So from the crude oil, actually, it will be refined into so many different things. Okay, so imagine you have here your crude, okay, and this will actually go into distillation system lah. So distillation actually is a way for a solution to be separated based on its boiling point. Yeah, I hope you guys still remember your chemistry. Okay? Boiling point. Okay, so imagine just now in crude oil, it has so many different chain lengths of carbon. Okay, there's longer chain, the smaller chain. So with longer chain, you can expect that the boiling point will be higher. Okay, with shorter chain, the boiling point is lower. So what that means is that it will turn into gas at a lower temperature if we're talking about shorter chain length carbon. Okay? Whereas if you have a longer chain, okay, it's harder to boil. Okay? Because of that, it will have a higher boiling point. Okay? So the temperature required would be much, much higher. So what's happening in the distillation tower is that these so many different molecules will be separated according to its boiling point. Yeah, so the heavy ones, it will go to the bottom because it remains as a liquid. However, the shorter chain length, okay, like methane, as it goes into the distillation tower, it will go up because it turns into gas. Okay, so that is the way in the oil refinery, how they actually refine this crude oil. Okay, from something that has a mixture of so many different things, you can now have something that is purified. Okay, so imagine at the top is hydrogen. Hydrogen is the lightest you can get from the crude oil. Okay, and hydrogen here will go to a hydrogen plant, and it actually becomes a resource for all the other processes. Okay, and then you have gasoline. Okay, gasoline is what you use in your car, a petrol car. Okay, diesel, of course, use different. So you have gasoline, you have kerosene, and minyak tanah, if you've ever heard about that. You have kerosene, you have diesel. The diesel is actually lower. It has a higher boiling point, yeah, so it remains as liquid. Then we have, so basically, the point here is, of course, there's a lot of information here, yeah? Okay. But what is most important here is that out of the crude oil just now, okay, only 58% is converted into gasoline. 7% is converted to refinery fuel gases and propane and butane, and 28% is actually the distillate, which is usually the heavy ones. It's used for jet fuel, for diesel, for heating oil, right? Now, sorry. Okay, applications of petroleum. Of course, the first things first is transportation. That is undeniable. So the share of transportation accounts for 55% of the oil used. Okay, and in the US, actually, the share is 70%. It's much higher because they have a higher amount of cars. Okay, and transportation, it has a limited possibility to substitute with other forms of fuel. Okay, why? Okay, let us make that as one of the questions for this week's mini quiz. Okay, try and think about why you cannot substitute petrol with something else in your car. Just have a think about it. If you find an answer, then answer in the Google form, okay, while you are signing your attendance. Okay. So the rest of it is used for other things. So it's lubricant, plastics, fertilizers. Yeah. Now, so we are still talking about the oil dependency. Okay, these are some of the things why the world depends a lot on oil. The price, relatively low cost, despite people saying, oh, mahal lah minyak. It's very expensive lah minyak, oil, in terms of the petrol lah. But actually, compared to alternative types of fuel, it is relatively cheaper. Okay. So the environment, minimal waste, it does have CO2 emissions though. Yeah. Safety, it is relatively safe. There are some risks which is associated to the transport, because it is being mined, or it is being extracted in a place very far from land. And so how you're going to transport that sometimes is an issue. Okay. So oil is also flexible. It has so many different uses, not only petrochemicals, plastics, fertilizers, so many different things that is being produced from petroleum products. And it is easily stored. If you cook at home, you have that large LPG tank. It is easy, isn't it? And even if you go for camping and you bring those cooker with butanes, it's easy because you can just bring that. You don't need to have, imagine you are in the forest, you don't have electricity. So this is very, very flexible. Yeah, it's very reliable because you just heat it up, you just spark it off, and then it becomes fire, isn't it? And then the energy content is also high. Yeah, transportability is good because it can be in liquid form, then you can just transport it anywhere. And the occurrence, it is localized. So meaning that you have a deposit, you have a place where it is collected, right? And you can just extract it rather than you have to go here and there. You got 5% here, you got 10% there. Yeah. So that is some of the reasons why we depend a lot on oil. And the world actually, not only us, and the world at large basically depends on oil. Okay, so that's about coal and petroleum. Now we go into nuclear. Okay. So I know that this may be a bit too out of your scopes, but please bear with me. it's interesting to know how nuclear energy is being produced. Okay, so how does nuclear plant work actually? They use nuclear fission. This is a process known as nuclear fission. So nuclear fission, this happens when large atoms split into one or more smaller atoms. Okay, and when this happens, it gives off particles, it gives off energy. Okay. This can happen spontaneously, in which it is called radioactive decay. Okay. Or you can actually force it to happen. Okay, so the word here is happen on demand in a process called nuclear reaction. Okay, and because this is a nuclear reaction, it is called nuclear energy. Okay, so what happens is you have uranium. I'm sure you guys have heard about uranium. Okay, so 235, meaning that it has 235 atoms. Yeah, the molecule itself. So here is the uranium-235. Okay. So what happened in the power plant is that it fires one neutron, okay, at the atoms, and when that happens, it splits. Okay. This split forms unstable radioactive isotope of uranium called krypton and barium. Okay, this is number 3, krypton and barium. So in this process, and while it is being split, this process actually releases a lot of energy. Yeah, and plus 3 spare neutrons. Okay, imagine now, previously we only use 1. Okay, you fire that, it forms 2, and you still have 3 more neutrons. And these neutrons will fire to the other uranium atoms. Okay, and that will happen as a chain reaction. Yeah, and you can imagine the amount of energy the amount of heat that is being generated from this process. Right? So this thermal energy is actually, it is being converted into electrical energy. It's very similar to power plants. It has the same thing. It has, of course, at site it's different, but the concept is similar. Yeah, so you will have the boiler, okay, which is where the reaction happens. Okay? And same like coal just now, it is being burned to generate heat. Here, the heat is used to heat up water, okay, generating steam. Okay. Steam here goes into the turbine, okay, and turbine here will turn. Okay, and as it turns the generator. Okay, and generator here is the thing that actually generates the electricity. Okay, so actually from here to here, from here, the steam generation up to here, it is similar to the conventional power plants. And what is different is just the resources. Right? And of course, if you have a nuclear reactor, there are things that you have to look into lah. Make it more safe, make it more usable. Okay. So nuclear power actually, it has its pros and cons. Pros actually has no greenhouse gas emission. It's very fuel efficient. It is resilient in times of extreme weather. So you don't really have to depend on the condition of the weather. For example, like solar power, and what happens when it's windy or when you cannot see the sunlight at night. You won't be able to generate electricity. The same with wind energy. If there's no wind, then you won't be able to get any energy. Yeah. And that's not going to happen with nuclear power. However, it does have its cons. Accidents could emit radioactive material. Yeah, and this is also one of the major things, how you want to dispose of the radioactive waste. That is a very big headache. And lastly, it is not a renewable fuel source because you have a limited amount of uranium. Okay. So if we just compare fossil fuels, the advantage is that the conversion of chemical energy into electric energy is easy. Yeah. Just like what I mentioned before, the power plants, most of the concepts are similar. You just heat up water, the steam will turn the turbine turn the generator generates electricity. Okay. And they are actually inexpensive and easy to transport. However, it does have its disadvantage. It is finite, means it's going to be finished lah. Yeah. And the extraction and consumption of fossil fuels threatens the environment through pollution, ecosystem disruption, and climate change. Okay, so that's it for this video. Okay. Looking forward to see you in the next video, which is on the renewable energy resources. Right? Thank you and bye.